The need for automation is increasing, and robust electric linear motion solutions are needed to make things move. These electric linear actuators use a wide variety of screw technologies as the driving force behind their motion. Selecting the best screw technology depends on several design factors for a specific application. These design factors will include expected life, force range, speed, and precision, to name a few. Two of the most common screw technologies used in industrial linear actuators are ball screws and roller screws. It is important to understand the benefits and limitations of both technologies. The power density of a roller screw enables more power in a smaller package than a comparably sized ball screw. With more contact points and increased contact surface area, roller screws distribute the load more effectively than ball screws. By contrast, ball screws of similar size have lower contact surface area, which decreases force capability and life, but increases efficiency for high-speed applications. Roller screws have efficiencies in the 80% range. Ball screws have efficiencies in the 90% range. This is due to having fewer contact points, producing less friction, and resulting in less heat during movement. Both types of screws come with a wide variety of leads. The lead is the pitch angle of the thread, and variations in this angle allow them to operate at different speeds and produce different forces. Dynamic load rating, abbreviated as DLR, is a universal expression of life for bearings and screw technologies. DLR rating is the force where a ball bearing or screw will achieve 1 million revolutions of rated life. Expected life is often communicated as the L10 life estimation. This is the point where 10% of the component population would begin to show initial signs of wear. The L10 calculation uses a cubic relationship of the ratio of dynamic load rating to equivalent load. This cubic relationship means that a roller screw that has a modest DLR advantage over a ball screw will have a significantly higher L10 rating on its life. The result is that roller screws generally have much longer life than ball screws. There are two types of roller screws, planetary and inverted. Both designs have pros and cons. Inverted roller screws have a more compact size than planetary roller screws, while planetary roller screws have higher life and DLR ratings. There are differences in load capability and life due to the manufacturing processes. Tolomatic manufactures the planetary roller screw design, where first the metal is hardened through a heat treatment process before machining the threads. The hardening process changes the microstructure of the material to increase its strength and hardness to a specified depth that is greater than the eventual depth of the threads. This process of significant heating and cooling the metal can distort machine features, which is why the planetary roller screw grooves are machined after the hardening. On the other hand, manufacturers of the inverted roller screw typically machine the grooves first, followed by a less robust hardening process, resulting in a much thinner layer of hardness across the surface of the threads. Because the depth of the hardened material on the planetary roller screw is 100 times greater than that of the inverted roller screw, it is capable of handling higher loads, lasting much longer, and is far more resistant to deformation from shock loads. This can be especially important in applications where most of the working time is spent on a small section of the thrust rod, like a pressing or high-frequency oscillation application. For applications that require high force, repetitive cycles, and long expected life, planetary roller screws are ideal. In summary, roller screws and ball screws both can offer high repeatability and accuracy. The ideal screw technology for each linear motion installation is based on its design requirements. Tolomatic offers both planetary roller screws and ball screws, ensuring the right technology is available for each specific application of industrial electric linear motion.